Imagine just pulling out the phone you already own, looking up at the night sky, and connecting directly to a cell tower floating in low Earth orbit. It sounds like sci-fi, right? But it's happening. In this explainer, we are diving deep into the massive disruption of the AST SpaceMobile 5G satellite network in the fast-approaching 2026 technological landscape. We're going to break down this incredible convergence of space-based connectivity, artificial intelligence, and next-gen computing that's about to fundamentally rewrite how humanity interacts with data.
So what exactly is the next trillion-dollar tech frontier? Well, the sheer scale of the disruption we're about to unpack is mind-blowing. When we talk about high-growth sectors that are fundamentally changing our planet's infrastructure, the most explosive opportunity isn't actually on the ground anymore. It's right above our heads.
The financial stakes of this new space economy are absolutely staggering. Look at this. Zacks research highlights that space is projected to become a literal trillion-dollar industry, and satellite-based communications are primed for just explosive growth. We are seeing massive institutional capital rushing in to fund networks that are going to blanket the Earth. And honestly, these predicted revenue breakouts, they're just the tip of the iceberg for a massive systemic shift. Now, space internet is just the beginning. Here's our roadmap for today. First, we'll look at the space internet revolution. Second, telecom's expansion beyond core. Third, the AI and robotics boom. And finally, the quantum computing leap that makes all of this possible. Let's get into it. Section 1. The space internet revolution. Okay, let's talk about the game changer, AST SpaceMobile's 5G disruption. The craziest part about this is that they are completely eliminating the need for special hardware. They're beaming 5G directly to the exact phone you already have in your pocket. This is all thanks to insane engineering feats like the Blue Walker 3 satellite. Picture this, it unfolds a massive 693 square foot antenna right there in low Earth orbit. Suddenly, your standard smartphone is a satellite phone. Backed by heavyweights like AT&T and Vodafone, this is the world's very first space-based cellular broadband network, and it's literally erasing connectivity gaps across land, sea, and air.
To put this into perspective, think about traditional infrastructure. Why spend years and billions of dollars digging trenches and laying fiber optic cable over massive mountains when you can just beam a connection down in a matter of weeks? India's government telecom company, BSNL, absolutely gets this. They're exploring a massive partnership with Starlink to completely bypass ground infrastructure. We're talking about instantly targeting the 40% of rural India that lacks basic connectivity. It is a total paradigm shift. And when you dive into the pre-IPO SEC filings, you see this fascinating financial dichotomy within the newly merged SpaceX and xAI conglomerate. They're seeking a history-making $1.75 trillion valuation. Basically, SpaceX is using Starlink, which is an absolute cash cow, generating over $11 billion in revenue, to fund a massive $14 billion capital drain for their xAI division. They are burning through billions just to train AI, even securing a $60 billion option to acquire the AI coding startup Cursor. It's an unprecedented mobilization of capital. Moving to Section 2, Telecom's expansion beyond core. With all these space-based solutions moving aggressively to cover the globe, traditional ground-based operators are being forced into a massive identity shift just to survive. McKinsey's trend report outlines exactly how legacy telecoms are using mergers and acquisitions to pivot. They're shedding underperforming regional markets and aggressively buying into high-growth tech. You see, your traditional internet provider doesn't just want to sell you a cable connection anymore. They're transforming into platform-based tech companies, heavily pushing cybersecurity, cloud computing, and comprehensive AI ecosystems. Which brings us to Section 3. The AI and robotics boom. Because all of this overarching global infrastructure feeds directly into an absolute explosion of artificial intelligence and physical robotics. That staggering $80 billion number you're seeing, that isn't a company's valuation. That is exactly how much stock Alphabet is selling off just to fund their upcoming AI spending spree. It really highlights the astronomical capital required simply to stay in the modern AI race. You literally need bottomless pockets to compete in 2026. The sheer velocity of AI capital right now is staggering. Look at Anthropic. They're a company that's only 5 years old, and they just raised $65 billion in a single go. That puts them on the absolute brink of becoming the fastest company in history to hit $1 trillion valuation. They're even renting compute power from SpaceX for $1.25 billion a month. I mean, the scale here is almost hard to comprehend. But it's not all happening in massive server farms. AI architecture is shifting away from the cloud and right into your pocket. We call this edge computing, and it essentially turns every laptop and smartphone into an autonomous brain. Processors like Apple's A17 Pro and Intel's Meteor Lake can handle real-time AI tasks, things like translation and voice recognition locally. That means almost zero power drain and absolutely zero cloud latency.
And the infrastructure backing these models is getting fiercely efficient. Take Grok's new LPUs utilizing memory alloy. This is essentially a way for AI to remember your entire conversation without having to reload it from scratch every single time, drastically cutting lag. Meanwhile, models like xAI's Grok 1.5 are generating highly cinematic, physics-accurate videos from simple text prompts. And Anthropic is allowing massive enterprise tasks to run seamlessly in a single session.
So AI is physically escaping the computer screen and entering our daily lives in a big way. We're seeing incredible leaps in consumer hardware. Have you seen the Unitree G1 humanoid robot? It can literally do side flips. Or the augmented reality smart swim goggles that project real-time biometrics right into your line of sight while you're underwater? Even giants like Apple and Amazon are battling it out, developing roving, tracking smart home assistants. It's wild.
Connecting this all back to our space and infrastructure theme, mobility innovation is just exploding everywhere. Down here on Earth, Kawasaki is debuting these super sleek, autonomous urban transit pods. Up in orbit, a Swiss startup is launching the Clear Space Suit in one mission to actively clean up dangerous space debris, while autonomous drones buzz around the ISS capturing data. The sci-fi concepts from the 1960s, they are finally being engineered into reality today.
Let's move to our final section. Section 4, the quantum computing leap.
We really need to look at the underlying hardware revolution here, because something has to process the truly astronomical amounts of data generated by all these space networks and autonomous robots. You see, classical computing is hitting its structural and thermal limits. Governments and tech titans know this, which is exactly why IBM is pouring $10 billion into quantum research. That's bolstered by a massive $1 billion federal award to build a dedicated U.S. quantum manufacturing foundry, targeting their quantum Starling milestone by 2029.
And they definitely aren't alone in this race. Using unique mobile qubits that drastically reduce system noise, Quantunium has mapped out a strict timeline to reach fault-tolerant computing. By 2029, their Apollo system aims for 10 nines of fidelity. To put that in perspective, it means the machine can run 10 billion operations before a single error occurs. Guys, this isn't just an incremental speed boost. This unlocks math that is fundamentally impossible for today's computers.
To wrap up this explainer, I want to leave you with this thought. We are watching AST SpaceMobile connect the remotest corners of the Earth directly from space. We're watching AI physically enter our homes, and quantum computers break the barriers of traditional physics. When the entire planet is instantly connected without a single gap, and our computing power is effectively infinite, what impossible problem will we solve first?